In this sample problem, we have a wheel that is a hollow cylinder of mass 3.6 kilograms approaching the bottom of an incline, and it's going to head up the incline with a tangential velocity of 6 meters per second. And we know that the angle of incline is 20 degrees. We want to know at what height above the surface does the wheel reach before coming to rest. Alright, so we're going to use conservation of energy in order to solve this. There's no spring, and we don't have to worry about friction in a rotational setting because, remember, we're not slipping or sliding, so that bottom of that wheel actually sits still. Alright, so that leaves us with initial tangential kinetic energy, initial rotational kinetic energy, initial potential energy, and then final tangential kinetic energy, final rotational kinetic energy, and then final potential energy. Alright, so whenever we do this, we have an incline, and the object is rolling up the incline, so 20 degrees in here. And what we're trying to establish is right here, where y equals 0, we know that the velocity is 6 meters per second. And we want to know what y final is here, so how far above the ground it is when the velocity is equal to 0 meters per second. Alright, so you see I crossed a few items off already. So because y initial is 0, I'm crossing off the initial potential energy. And because the object comes to a stop at the top, I'm crossing out our two kinetic energies. Alright, so we also have to remember, we can say v potential equals the radius of the wheel times the angular velocity. So I replaced here our angular velocity with v over r. I also looked up the moment of inertia equation for a hollow cylinder, which happens to be mr squared. And what happens is that when we distribute this square here, we end up with the velocity squared over the radius squared, which allows me to then cancel out the r's. And I'm left with just then the velocity squared times the mass. So now I can plug in my values. I have 1/2 times the mass times the velocity squared plus 1/2 times the mass times the velocity squared. When it is a hollow cylinder, it turns out the two kinetic energies look the same. And that's going to equal mass times 9.8 meters per second squared times our y final. So y final is 3.67 meters.